All right, Environmental Science 20, this is Chapter 8, and we're talking about hazardous waste. So I want to watch a video, and this is on the website. So if you go to mrmathwell.com, and you go to your course page here, Environmental Science 20, you should see, is the screen frozen? Okay, screen frozen. So you should see down Chapter 8, you have all your handouts and things there, the lessons, where are we, 5, 6, next one, 7, 8. Okay, so here's some videos that we watched already, and we'll have some more stuff here. Here's the news article that we're going to watch here right away. So you can watch that online if you wish as part of this recorded lesson. I'm not going to show it online for copyright purposes. So dioxins were the main hazardous sort of material in that train derailment, the fire in that town. Dioxins are what this video was mostly about. A group of highly toxic chemicals that are persistent environmental pollutants. They're found in the environment, food, and in the human body. So they also talked about vinyl chlorides, which we will talk a lot about in our notes here today. So as you can see from this video, it made it all the way to the president commenting on it. It was a big train derailment, a huge fire, releasing all sorts of toxic chemicals into the atmosphere in the town and around, and it still was smoldering days afterwards. And yeah, the issue that was raised was, how to safely move these materials, where to take them, and how can they be properly and safely transported. So a hazardous substance, okay, what is a hazardous substance? It is a harmful substance that requires special handling. So we have some kind of radioactive or chemically unstable or toxic substance that requires special handling. We're going to talk about these warning signs a little bit, but toxic, poisonous, there are several toxic signs, but this is the skull and crossbones, kind of the poisonous sign, right? So they don't call it poisonous anymore, they call it toxic. Explosive, looks like this, irradiation, this sort of radioactive symbol there. Acid, yeah, you'll see different signs for this kind of thing. Flammable, okay, so we have a big fire on that warning sign. And biohazard kind of always has this circle with the 3 sort of half circles like that. That's a biohazard symbol, but we'll talk more about those shortly. Hazardous substances are used in manufacturing products. Okay, you can't get away from using some substances that are hazardous to human health. One common hazardous substance is hydrochloric acid. And those of you that are studying chemistry, that's HCl. So hydrochloric acid, HCl. So a hydrogen bonded to a chlorine atom. Computers and circuit boards contain small amounts of poisonous metals, such as mercury and cadmium. So I have a little picture of a circuit board here. Mercury is Hg, cadmium is Cd. And you'll see that they're right next to each other in the periodic table, one right above the other. They have similar properties, numbers 48 and 80 there. And yeah, they are not good for us, especially, and mercury as well. Interesting story, when my mom was a kid in school, I didn't know so much about mercury, and mercury was not seen as being very dangerous. It was a very cool liquid. It was actually a metal, that was liquid at room temperature, which was very interesting. And that's why a lot of the old thermometers are made out of mercury, because it's a metal that's very predictable in how it expands and changes with temperature. And it's also a liquid at room temperature, so it can move up and down the column in a thermometer. And so my mom recounts, like, in school, they would have like this bottle of mercury, and they would like pour it out on the desks, and the kids would like play with it and stuff. It's like this liquid metal, and well, now we know that the body absorbs mercury through the skin, and it does not get rid of it. It's hard to excrete that, and so it builds up in all sorts of different corners of joints and your brain even, and so it's like it enters your body very easily, does not leave your body very easily, and so can cause a lot of problems. And so that's why we keep doing research. That's why we keep learning things, so that we can change our behavior that might be a little more healthy. Okay, but yeah, it's an interesting story. I remember my mom telling me that story because when I was in school, it was like a big no to touch mercury, you know. And even the thermometers, they don't make thermometers out of mercury anymore. It's more like some kind of, you know, just colored or dyed alcohol. Some materials are converted to non-hazardous materials when the product is used. For example, gasoline, hazardous substance. But when it burns efficiently, that is, if it were to burn completely efficiently and no leftover, sort of partially burned products left over, then it really only produces, as a result, heat, water, and carbon dioxide. Now, carbon dioxide is a greenhouse gas, which that's part of the reason why, you know, fossil fuels being burned produces, you know, carbon dioxide into the atmosphere. But generally, when you burn a hydrocarbon, and remember, I think I mentioned this the other day, but some kind of hydrocarbon is a carbon with hydrogen in it, and when you burn it, it's like adding oxygen. So this is O2 here. This is CO2. This is water, H2O, and then you have energy. And this energy is what's used to power the vehicle, right? The explosion, the explosive expansion of heat energy fires the pistons in the engine, and that's what turns the crankshaft and makes you move. So it all comes down to energy release. But yeah, so starting off with gasoline, not a good idea to touch it, drink it, you know, play with it. But when it burns, okay, a lot of that hazardous aspect of it is gone. So when we're talking about exhaust, and when we're talking about that, now exhaust from when your engine burns, there's some stuff in there, especially carbon monoxide. But if it doesn't get burned completely, or there's other, you know, buildup of other things in your engine, as part of that exhaust, there could be some other toxic things for sure. Hazardous waste is discarded substance that is or contains a flammable, corrosive, reactive, or toxic substance. So hazardous waste is discarded substances that are flammable, corrosive, reactive, or have a toxic nature to them. So on page 245 in your textbook, if you're looking that up, we do have a chart of hazardous materials, their symbols and descriptions. So let's just pause for a second and take a look at that. Okay, so the first symbol is this right here, the kind of the fire with the line underneath it. This is the flammable and combustible materials symbol. Flammable and combustible materials are materials that present a fire hazard or can ignite or explode easily. Okay. So gasoline, paint thinner, kerosene, matches, naphthalene, things that will light up pretty quickly and pretty easily would have a flammable warning label. Now, two, corrosive materials. This is typically your corrosive materials symbol, where they're actually pouring little bits of whatever this corrosive material is. It's eating into a metal bar here, or it's eating into your hand. Ouch. That's the symbol. So corrosive materials, they're materials that corrode or chemically destroy other materials, including human skin. Corrosive materials that corrode or chemically destroy other materials, including human skin. Okay, all sorts of like acids and different things like that. Number three, reactive materials. Reactive materials can explode if improperly handled. So this is not necessarily have to do with heat or fire. This is like if you shake them too much or something. Like they could be that volatile that if you shake them or drop them, boom, could explode. Ooh, not good. So they can explode if improperly handled or react violently with other substances. So if you have a reactive substance that mixes with the right other thing, it could be lights out. Yes, see all sorts of, lots of metals, even sodium in water, boom. That's a metal. If you put a little chunk of sodium metal in water, it will immediately light on fire. And if it's big enough and can't, you know, if the inside gets too hot and expands too quick before the outside burns, then it plops and explodes. Yeah, so sodium's a big one. Number four, toxic. So toxic and infectious materials can kill or seriously harm people or other living organisms. There are three subcategories for the toxic and infectious materials. So the first subcategory would be substance that cause immediate and serious effect. And you see the skull and crossbones, that's kind of the old poisonous sign, right? So immediate and serious effects from toxic materials would have a symbol of skull and crossbones. Those that have long-term effects, so radioactive. This symbol is one that's common, and this symbol with the T that kind of is morphed into an exclamation mark. You know, hazardous, toxic. So the T there, it's like, you know, beware, toxic. But yeah, I found this one a lot too. So yeah, radioactive. I don't know. This is kind of like. It's, you know, there's radioactive radiation happening inside a person. I don't know if that's what that kind of means, but long-term effects. And then finally, biohazards. That's just this unique symbol here. A biohazard is a biological natured agent that is hazardous to humans or the environment. So it has some biological nature to it. It's part of, or it is a living organism. It's hazardous because it's bio in nature. Okay. So those are the three subcategories, and again, that's all laid out on page 245 of your textbook as well. Any questions so far? Things going good? Okay. All right, a persistent pesticide, which we talked about, the dioxin, right? The dioxin is a persistent, what do they exactly call it again? POP, persistent environmental pollutant. So a persistent pesticide, for example, is one that does not break down or takes an extremely long time to break down, and therefore remains in the environment for a long time. So pesticides are used to kill pests, right? Pesticide, pests. Herbicide would be chemicals that are used to kill weeds, like herbs, plants. Pesticides are pests, so insects and things like that. A chlorinated hydrocarbon is a hazardous chemical used to make products such as pesticides, solvents. Solvents would be materials that are organic in nature, usually that are used to dissolve other things or to break down, like cleaning paint off of something or whatever, solvents, something that dissolves something. And pipes, so plastic pipes like PVC pipe. You heard of that before, right? Very, very common in drains and plumbing and stuff. The plastic itself is not that bad, but the chemical, once it's heated or burned or, you know, that kind of thing, it can get nasty. PVC is polyvinyl chloride. That's what it's called. Now, this is a picture right here of a chlorinated hydrocarbon. So when you get to chemistry 30, there will be a unit in chemistry 30 called organic chemistry. And organic chemistry involves carbon-based molecules. And this, because it's got chlorine attached to, and it's hard to tell here, but you will find that at these junctures of the lines, there's a carbon atom there. There would also be some hydrogen atoms that are not shown. Generally in these sort of chain, abbreviated sort of chain structures here, they don't show the carbons on the interior of the chain. They don't show the hydrogens, but they do on the ends. So these chlorines have displaced some hydrogens, and you have now a long carbon chain with chlorines on it. So that's called a chlorinated hydrocarbon, and it's a main constituent in pesticides. Right? And then PVC stands for polyvinyl chloride. All right, DDT. I'm not sure if you guys have heard of DDT before. DDT was developed as an effective pesticide over 50 years ago, but has been banned because of its links to reproductive problems and nervous system conditions. So this is also another type of chlorinated carbon, but also this has phenol. Okay, this is a phenol functional unit here. So this is biphenyl, or in this case diphenyl. So dichloro, so there's the two chlorines on the side. Diphenyl, this is a phenyl group here. Trichloro, there's the three chlorines. Ethane, so ethane is a organic molecule with two carbons in length, two carbon chain. So that's what this molecule is called, dichloro diphenyl trichloroethane, DDT. And you can see why they abbreviated. They don't want to be saying that all the time. But yeah, I mean, fairly innocuous looking, I suppose. Doesn't look like, hey, it shouldn't be that big of a deal. What's the big deal? But, you know, visual representations of very harmful things often look sort of like they shouldn't be a big deal, but it's a big deal. Yeah, big deal. How that affects other things, how it breaks down, the reactions, how it gets stuck in your body, that kind of thing. Lots of stuff that you should be worried about. So we just have to be careful around these substances, right? That's why I mean, that's why even going back here, like when you're spraying pesticide, you got to wear like protective material, right? You don't want that stuff to rust on your skin, get absorbed into your body, mess you up. Okay, so you got to be careful. That's why you need gloves, that's why you need goggles, that's why you need sometimes a hazmat suit to protect from any vapor that may be drifting onto your skin or clothes.
Or you will be the pest.
Yeah, or you might be the pest, yeah. Now, most of those pesticides won't kill you, but they might make you very sick, and there could be some long-term effects you don't know about. So heavy metals, let's talk about heavy metals. Well, I'm not talking about, headbanging heavy metal stuff. Heavy metals are dense metallic elements, which include arsenic and lead. Kind of see, lead is Pb, arsenic is As there. So As is 33, lead is number 82 there, Pb. Lead. Anybody know why lead is Pb and not like L or Le or something? Anybody? Okay, yeah, there's two main reasons. It's named after a discoverer, like a person, or it's from the word in another language, and that's the case here. So the Latin term for lead is plumbum. Plumbum, so it's Pb. Yeah, cool. Right? Yeah, lots of them, like sodium is Na, that's natrium. Potassium is K for kalium. Yeah. Tin is Sn for stannum. That's the Latin word for it. Yeah. These are dangerous elements because they accumulate easily in the body. Mercury, cadmium, remember I mentioned that? They accumulate easily in the body and they're very difficult to get rid of. Our body does not excrete these metals and they can cause cancer and all sorts of problems. Brain issues, brain problems. You get these metals deposited into your brain and it starts to affect how your brain works. So page 247 in your textbook, so if you want to turn there, if you have a textbook on your table, outlines common products and the potential hazardous waste that they produce. Study this chart and make some notes below. So I'm going to give you 5 minutes or so to do that right now in the middle of this class. So I didn't put this in your notes because I wanted you guys to make some notes, but for example, I'll read a few things here. The products that we use, plastics, okay? The potential hazardous waste they generate, organic chlorine compounds, like the PVC and the chlorinated hydrocarbons. Pesticides, organic chlorine compounds, and so on. Now it goes down to medicines, paints, oil, gasoline, other metals, even leather and textiles. So please take a moment to read that, study that, make some notes. You can make a note on each one of those or just some of the ones that you don't think you're going to remember. But take 5 minutes or so and do that right now, please. Okay, so just a note here. In that chart, you will see that oil, gasoline, and other petroleum products produce oils, phenols, organic compounds, heavy metals, ammonia, salts, acids, and caustics. So caustics is not a word that you see very often. So caustics are materials capable of burning, corroding, or destroying living tissue. Okay, so yeah, all these sorts of nasty chemicals can burn your skin, corrode, and overall just singe or destroy your skin tissue and all that sort of stuff. So that's what a caustic is, capable of burning, corroding, or destroying living tissue. Yeah.
What's the difference between burning and corroding?
Burning is involving oxygen, I suppose. Corroding is not necessarily involving oxygen.
Take away the oxygen in your body, right?
Burning is a combination. When they say burning is a combination of oxygen to generate the reaction. You might see a flame, yeah, but you probably wouldn't see a flame, no. There's not, burning, corroding, and destroying, very slight differences, which we won't really get into now. That'll be bio or chem, but just so you know, destroying living tissue. All right, let's keep going. Components electronics are another hazardous waste problem, as we've mentioned before. PCBs, this is close to PCV, or PVC, I should say, but PCBs, polychlorinated biphenyls, okay? And the DDT had the kind of like diphenyl, biphenyl. Actually, should that be a BI? Should almost be a BI, I think, biphenyls. I think that's wrong. Yeah, that's a BI. This should be an I. So polychlorinated biphenyls, that's BI, are extremely harmful chlorinated hydrocarbons. They are fire-resistant and heat-resistant compounds that conduct electricity. These have been found to accumulate in human and animal tissue through contact over time. They can harm the immune system, the nervous system, the respiratory system, and the reproductive system, as well as the urinary systems. PCBs are also thought to cause cancer. So PCBs are something that was, big in the news decades ago when they first started being, making these connections to these chemicals that were used in lots of different things, and electronics and things like that, and health issues. So there's not as much talk about them anymore because they're banned a lot now, but they were more common back in the day. So I do have about a 10-minute documentary I'd like to show you here, PCB's documentary. So let's just go there, open hyperlink. And again, I won't show the full video here on my video, but
PCBs.
you can watch this again. This should be PCB's video right here.
Stand for polychlorinated biphenyls.
Okay.
So for this, we're just going to call them PC.
Yes, thank you. No one told you could start again. Okay. All right. So how are we for light situation here? Okay, I'm going to pause the video and then we'll watch this in class here. So the video was largely about accumulation of PCBs in waterways and in fish and in humans, and the fact that that these harmful chemicals don't really dissolve or disappear. They accumulate and can stay in products and people for dozens of years, decades, generations even in waterways and different things like that. So so this is a list of where PCBs might be in your home or in your garage or in your basement, in your yard. Adhesives, tapes, and plastics as well. Yeah. So what I want you to do is make a little note at the end of your or somewhere around here. I want you to do. You have a little assignment I'm going to give you here. So I want you to find out what products in your home may contain PCBs, and assess. And again, this is pretty subjective, but assess the danger in your exposure to these things. All right. Now, there's like I say, there's no real objective way of assessing your danger in this. What I'm saying is that if you can't find anything in your house that has PCBs in it that you come in contact with at all ever, then you have a pretty low risk. Okay. But like I mentioned, let's go back to that list, right? The lighting, even they said toothpaste and stuff. So find out what kind of chemicals specifically are PCBs. Check your makeup, your toothpaste, the cereals you eat, the packaged burritos or whatever, your snacks, cookies, the things that you touch and use, like your curling iron and stuff like that, Noah. All of your makeup, yeah, you better check on that stuff that you have exposed to. Yeah, exactly. So different plastic products, different chemicals that you use maybe to clean your face or to wash your hands or whatever. So cleaning, products and that kind of thing. So find out what products in your home may contain PCBs and assess the danger in your exposure to these products. So you may have a list of 10 things in your house that, hey, you know what, you come in contact with, and this is a real PCB risk. You may have a list of 2 or 3 things only. So do some research. Again, you can go to the net. What kind of things? I mean, everybody handles electronic equipment. Are you protected from that or not? Are they deep inside the computer? Are they on the keyboard, or are they on the switches and metal components, or what? Plastic, you touch a lot of plastics, okay? How much PCBs are they? Where are you going to find those? So do a little more research on these polychlorinated biphenyls and assess your risk in your home.
Mr. Maxwell?
Yes.
Isn't that the PCB has?
Yeah. So I'm not looking for you to do a chemical experiment like experiment with things and to identify in the lab that there's PCBs here. And I know they've been banned, but there's unregulated parts of the world that produce a lot of things that we come in contact with. So there's still some around. Even though the water, like, are there PCBs in our water? Okay. Look up the juices, the foods that you eat. Could PCBs get into the stream anywhere? So yeah, I just want you to do a little bit of a deep dive in this and find out if there's any risk that you can come across here. So we'll pick up the last half of this tomorrow.